Okay, so for the following circuit here, we have to get the transfer function and then sketch its frequency response. So what we're going to do is do a mesh. So let's call this I. So we have minus Vs plus IR plus, oh yeah, sorry, we should get the impedance values first. So the impedance value for this resistor is just R, and for this inductor, it's going to be J times the angular frequency times the inductance value. So it'll be minus Vs plus IR plus JIWL. Okay, so Vs will just be equal to IR plus JIWL. Okay, good. So now we need to find VO. VO will be equal to the current times the impedance value of the inductor. So the current passing through the inductor times the impedance value of it. So it'll be so J times IWL. So now let's find the transfer function. It'll be equal to VO over Vs. So JIWL all over IR plus JIWL. Let's factor out the I. So this and this cancels out. And now we're left with JWL all over R plus JWL. So this is pretty much your transfer function. Now we have to sketch the frequency response. So we're going to continue. We're going to take the conjugate of this. So it'll be R minus JWL. Wait, so pretty much the frequency response, it's going to be a graph of the magnitude and the phasor of our transfer function. Okay, so it's pretty much going to be a graph versus the angular frequency. So I'll quickly get to doing all of that. So this will pretty much equal to JWRL plus W squared L squared. Remember how complex numbers work. J times J is minus 1. Then we have this minus here, and then it's R squared plus W squared L squared. Okay, now let's break this up. And notice the following. So I'll put this J here. We have the imaginary component and the real component of our transfer function now. So let's get the magnitude of our transfer function. So pretty much this is how we get the magnitude. Okay, so follow this into all of here. And this, oh yeah, wait, sorry, let me go back. Sorry, and all of this is to the square root. Sorry, I forgot to include that. So distribute the square into all of this. And same goes for this one. And now you see we have a common denominator, so we can just add these up. Now the square root, we can square root these individually, and we see this and this cancels each other out. So we're left with the square root of W squared R squared L squared plus W4 over L4 all over r squared plus w squared L squared. Now, the next thing we're going to do is factor out this even more. So I'll take, let's see what I could take. I could take w squared and L squared out of all of this. And I could square root these individually. And this and all of this cancel each other out. And what I notice is this and this are both the same. And remember, a square root is pretty much something to the power of 1 over 2. And this is to the power of 1. So 1 over 2 minus 1, that's equal to minus 1 over 2. So I can rewrite all of this as minus 1 over 2. And then I could just bring this down. So it'll just be WL all over R squared plus W squared L squared 1 over 2. And this is just, to the square root. Alright, so we pretty much got the magnitude down. Now let's get the phasor. So the phasor part, it's pretty much tan inverse of this all over this. So tan inverse of the imaginary all over the real component. So it'll be WRL all over R squared plus W squared L squared all over W squared L squared all over R squared plus W squared L squared. This and this cancels each other out. So it'll just be WRL all over W squared L squared. This and this and this and this cancels out. So it'll be R over WL, tan inverse of that, obviously. Now what we're going to do next is set a variable called omega L and set it to be equal to R over L. Okay, that way we can make it easier to make our frequency response function. Sorry. So I need to have everything in terms of VO and WO and W. So this will just be WO over W. Now I have to find a way to fix this up. So what I could do is to factor out an L. So take an L squared from all of this. And I could take the power up here. And then square root these individually. This and this cancels out, and then this and this cancels out. So we just have the following. Okay, so that looks good. And this will just be WO. And I could go a step further and make this look much more nicer by factoring out a W squared. So hold on, let me redraw this more clean. Okay, so I'll factor out the W squared from all of this. So then break the square root up. This and this cancels out, and this cancels out. And bring the square up here. So I can rewrite this as the following. Alright, and then tan inverse of WO over W. Now let me graph all of this. So I'm going to have this chart. So this one is going to be W over WO. So 0, 1, 2, 3, 4, 5, and 6. Here it's going to be my magnitude value, and here it's going to be my phasor value. So pretty much so notice how this and this is the opposite. So when W over WO is equal to 0, we have to take the reciprocal of that and then put it into here and here. Okay, so the reciprocal of 0 is just 1 over 0, which is undefined, but in this case we're going to take it to be infinity. So this will be infinity squared plus 1, which is just infinity, and the square root of infinity, which is just infinity, and it's 1 over infinity, which is 0. And then tan inverse of infinity, that's 90 degrees. Now when it's 1, this is 1, this is also 1, so it'll be 1 over, so this is just going to be 1 over the square root of 1 squared plus 1, which is just 2. And this is just going to be 45 degrees. There we go. Now for whoops, for 2, reciprocal is 1 over 2. So it'll just be 1 over 2 squared plus 1. And that's equal to 1.2, 1 over the square root of 1.25. And putting 1 over 2 into here, we get 26.565 degrees. Now let's do 3. So it'll just be 1 over 3. We put that into here, and we get 1.11. So it'll be 1 over the square root of 1.11. Put 1 over 3 into here. We get 18.4349 degrees. Now let's do 4. So 1 over 4 here. And that's 1.0625. 1 over the square root of 1.0625. And its degree will be 14.036 degrees. Now 5, then it's 1 over 5. Plug that into here. 1.04. And then put 1 over 5 into tan inverse. Then you get 11.309 degrees. And the last one is 6. And putting that into here, you should get 1.0277. And then putting 1 over 6 into here, you get 9.4623. Now let's start graphing this out. So we have our magnitude here, and then we have W here. So W is equal to NWO, okay? So W over WO is equal to N being these numbers. So W will be equal to NWO. So 0, WO, 2 WO, 3 WO, 4 WO, 5 WO, and then 6 WO. Okay? So notice for so pretty much when N is 0, then W is obviously 0, and then H is also 0 at the same time. And then notice as N increases, our H value approaches 1, but never actually equals 1. So it's going to look something like this. So it's going to approach 1, but never equal 1. And now for our phasor one, same thing. So when W over W, when N is 0, we have our phasor to be 90 degrees, and as we increase our N value, our degree starts decreasing like that. Okay, so yeah, there's your graphs.